Okay, good morning. So next we'll see about next topic, that is Arden's theorem using converting our DFA to our regular expression. So how we are going to convert by using our Arden's theorem. So the formula for Arden's theorem is R equal to Q plus RP. So this is the formula R equal to Q plus RP. If any of our equation in this particular form R equal to Q plus RP form, then we have to convert that particular statement into final expression as QP star. Okay? So this is our Arden's theorem method. So let us see some example how we are going to convert this particular statement into this particular thing. So consider this example. So construct regular expression from the given DFA. So we have totally three states, Q1, Q3, Q2. Over here, Q1 is my starting state as well as my final state. So now, how we are going to use the Arden's theorem. So first what I have to do is, there are totally three states. First I am considering my Q1. So how I am going to find out the solution is from where the input is coming to my q1 state. So those inputs I have to take and write in this, like considering in this equation method. For example, if I take q1 state, the input is coming in my self loop 0 itself. So I have to take and write it as q1 0 over here like this. Then plus, then after that from q3 the input 0 is going to my q1. So q3 0, and since q1 is my starting state, default we have to take and write this epsilon symbol. So whichever is my starting state, I have to mention my epsilon only for my starting state. So this one will be my equation 1. Same thing for q2 state. From q2 state, the self loop q2 self you're generating 1. So q2 1. Next, from q1, the input 1 is coming to my q2. So q1 of 1. Next, from q3 state, the input 0 is going to my q2. So this one should be 0. Actually, it is not 1. This should be 0. Okay, q3 of 0. So this will be my equation 2. Last, q3. So for q3, from q2 only, the input 1 is coming to my q3. Rest of the states I'm not getting any inputs. So q2 of 1 over here. Okay, q2 of 1. This is q2 of 1. So this will be my third equation. Now we have taken and found out equation 1, 2 and 3. So next step, after finding out this, forming this equation, next I have to substitute. So next what I have to do is, over there q1 was my final state. So after finding out the solution in q1 only, I will be finding out my final expression. So what I have to do is, I am going to take the q1. If I take that q1, there is already this q2 and q1 are present. So directly I cannot form that equation and bring out the expression. So what I'm going to do is, I'm going to substitute 3 to second. Okay, I'm going to substitute my third equation to second equation. So if I take my q2, this is the value q21, q11, then q2 of 0, 1. So this particular thing already it is in our q plus rp form. So this q2 over here is q1. So what I'm going to do in next step is q2 of 1 plus 0, 1 plus q1 of 1. So commonly I'm taking q2 outside. So q2 bracket 1 plus 0, 1, and rest this q1 1 I have taken and written. Now if you look, this one is, it is in the form of q plus rp equal to qp star. So this q2 is nothing but my r, this whole term is my p, and this term is q. So now the final expression what I have got for q2 is q11 bracket 1 plus 0, 1 the whole star. So this is my fourth equation what I have found. Next, Now whatever the fourth equation I have found, now I have to substitute that in my first equation. So q1 0 plus q2 of 0 0 plus epsilon. Now if I substitute that one, so q1 0, then q1 of 1 bracket 1 plus 0 1 the whole star 0 0 plus epsilon. So now this one is in the form of this particular expression. So q1 commonly I am taking out, so 0 plus 1 bracket 1 plus 0 1 the whole star 0 0 plus this whole term is my q. So 0 plus 1 bracket 1 plus 0 1 the whole star 0 0 the whole star. So at last I am eliminating my epsilon, and this is my final expression. So this is my final output what I am getting in my q1 state. That is, my q1 was my final state, so this is my final expression, regular expression. Next, let us see another example. So example 2. So over here we have three states, q1, q2 and q3. Over here q2 is my final state. So how I am going to take and write my expression? So if I take first q1, if I take q1, q1 has self loop a, so q1 of a plus epsilon. Since q1 is my starting state, I told default I have to take and write it as epsilon over here. Next I have my q2. So if I take my q2, from q1 the input b is coming to my q2, so q1b, so I have to take and write. Next q2 self loop b is there, so q2b. So this will be my second equation. Third equation, actually I have not written here, so q3 equal to, from q2 only is coming to my thing, so q2 of a. So this one will be my third equation. Okay, so this one will be my third equation. Now in this final state q2 only I have to find out my expression. So after finding out these three equations, now what I'm going to do is, if I take my q1, already this q1 is in the form of my q plus rp qp star. So what I'm going to do, q1 equal to q1a plus epsilon. So this q1 is going to be my r, then equal to epsilon plus q1a. So q, as I told you, it is my epsilon value, r is nothing but my q1 and p is nothing but my a. So q1 equal to a star, epsilon a star, and q1 equal to a star. So that will be my q1 answer. So as I told you, q1 is my a star over here. Next, now we have to substitute the value of q1, that is whatever we found that a star no, in my second equation. So if I substitute q2 equal to q1b plus q2b, so q2 equal to, instead of q1 I have to substitute a star b plus q2b. Now if I take this, q2 equal to a star b plus q2b is in the form of r equal to q plus rp, that is qp star. So a star bp star a star b. So this is, so therefore if I have b dot b star means it is b plus. So the final regular expression is a star b plus. So this is my final expression what is generated in my q2, that is my final state. Okay, thank you. That's it.